I am Anil Kumar. Welcome to my series on polynomials. We will now discuss polynomials in factored form and take up application-based questions. Here are some brilliant questions which have been asked in previous test papers, and I have found students struggling with these particular questions. So it's a good idea to solve them now and get ready for your test. I'll discuss with you 5 problems which are basically based on factoring skills. We'll take up difference of cubes and sum of cubes as the major factoring skill. I hope you remember the formula. A cube minus B cube is basically equal to A minus B times A square plus AB plus B square. If it is A cube plus B cube, in that case, the first factor is a plus b and the other factor is a square minus ab plus b square. So you can see the change in the sign, correct? So that will help you to remember the formula itself. We are going to use this formula to answer some of the questions, and then we will have application-based questions on this particular topic. We'll also see how do we graph after factoring. Here are the 4 test questions for you. These are from previous test papers. Question number 1. Sketch the graph of x cubed minus 9x squared plus 27x minus 27. Question number 2. Factor m to the power of 4 plus 15m cubed plus 75m squared plus 125m. Question number 3. X cubed plus 3x squared minus 9x plus k has 2 identical linear factors. Prove that the value of k is either 5 or minus 27. Question number 4. A cone is inscribed in a sphere of radius 2 centimeters. Determine volume of the cone in terms of x, that is v of x, in factored form. Write down the domain of the function v of x. So it has 2 parts. You have to also write down the domain of this volume of sphere. So we have shown you a cone inscribed in this sphere. You need to find the volume of the cone, right? So let's look into the first question and let's try to see how do we solve it. Sketch the graph of x cubed minus 9x squared plus 27x minus 27. To factor this, we may have to regroup. I would like you to pause the video, answer this question, and then look into my suggestions. So let us see what can we do about it. So we have x cubed minus 9x squared plus 27x minus 27. Let us rearrange. So we get x cubed minus 27. So I'm bringing this 27 here, and we have the other terms, which is 9x squared plus 27x. The first 2 terms, it is difference of cubes. It could be written as x cubed minus 3 cubed, correct? 27 is 3 cubed. Here we can factor 9x and we get x minus 9 times 3 is 27. Now applying the formula for difference of cubes, we can factor x cubed minus 3 cubed, which can be written as x minus 3 times x squared plus the product, which is 3x, plus 3 squared, which is 9, and we have this term as minus 9x times x minus 3. Now clearly, x minus 3 is common. So we can write this as x minus 3 times x squared plus 3x plus 9 minus 9x. Now that can be simplified, and so what do we get? We get x squared, 3x minus 9x is minus 6x. So we get x squared minus 6x plus 9. Can you factor it further? Yes, you can. You can see that this is a perfect square, right? So we could now write this as x minus 3 times x minus 3 whole square. So we get this as basically x minus 3 whole cube, right? So I could write this as, let me squeeze it in here, whole cube, right? So we could now factor this and write it as a cubic function. So let me rewrite this. So we get, let's say this is the function f of x. In that case, we can say the function of f(x) is basically equal to x minus 3 whole cube, correct? Now it is easy to sketch the graph. Basically, it's a cubic function which has moved 3 units right. Perfect. So that is how we can sketch this particular graph. And if x is equal to 0, in that case, we get a value which is, cube, right? X minus 3 whole cube. So if x is 0, we get minus 27 as the y-intercept. So we can actually sketch this graph as a cubic function where the 0 has moved to a point which is at 3, right? And the y-intercept will be at minus 27, since f of 0 is minus 3 cube, which is minus 27. You can plug in 0 here. You're going to say f of x is equal to this. And so when you put 0, you get minus 27. So that becomes the graph for the given function, correct? So that is how you can actually solve it. So here is the typed out solution for you and a neatly written graph, shown graph here. So you can see that place, right? So that is the graph of y equals to x minus 3 whole cube, which you get after factoring. Is that clear to you? So now, the two formulae which we used here were x cube minus, let me write y cube, in general will be x minus y times x squared plus yx, or xy, plus y squared, right? The other one was a perfect square, right? So we can write a minus b whole square is a squared minus 2ab plus b squared. Now let's look into the second question. Factor m to the power of 4 plus 15m cubed plus 75m squared plus 125m. You can pause the video and then answer this question. We have m to the power of 4 plus 15m cubed plus 75m squared plus 125m. So clearly m can be taken as common. So let's write that down. M cubed plus 15m cube plus 75m squared plus 125. Now difference of cube, we have, well, 1 power I should reduce, right? M we have taken common, right? Now when we have m cube, look here, 125 is 5 cube. So that helps. So we should reorganize this and we can write this as m cube plus 5 cube for 125, right? Plus 15m square and 75m. I can take 15m common. So I get m plus 5. 75 divided by 15 is 5. A cube plus b cube formula will be applied. So we get m plus 5 times m square minus 5m, their product, plus 5 square, which is 25. And here we have 15m times m plus 5. Now m is common and m plus 5 is also common. So m is already outside. We'll take m plus 5 also as common now. In that case, what remains here is m squared minus 5m plus 25 plus 15m. Perfect. We can combine these terms and see what do we get. So we have m times m plus 5, and here we get m squared minus 5 and 15m gives us plus 10m, and we have 25. So that is also a perfect square. So we can write this as m times m plus 5, and this is m plus 5 whole square, right? So this could be written as m plus 5 whole square, and that could be now written as m times m plus 5 whole cube. Right. So that is how we could actually factor this. Now it remains up to you to sketch this. Let us say y equals to all this. So let us make a sketch. I'll make a rough sketch here. So we have a quartic equation. There are two zeros, one at 0 itself, m, and the other one at minus 5. The 0 at minus 5 is cubic in nature. Do you see that? And because they are both positive leading coefficient, right side is up, right? So at 0 it's linear, so it will go down, and here it will be kind of going like this, right? This is a cubic 0, so I can draw like this. Do you see the graph? So that is how the graph will look like for the given function. Is that clear to you? Well, here is the typed out solution for you. You can look into all these steps which we did and exact graph which we have drawn. The point here we found was minus 5, and that is of course at the origin, right? So you get a quartic function shown by this particular equation. So this is independent variable m, let's call this m now, and that is y. So I hope till now both the examples are absolutely clear to you. We basically did factoring using difference of cubes and sum of cubes. Now here is a very interesting question. Question number 3. X cube plus 3x square minus 9x plus k has two identical linear factors. Prove that the value of k is either 5 or minus 27. How are you going to do this? What is the meaning of has two identical linear factors? Okay, so what I understand is that function x cube plus 3x square minus 9x plus k should be equal to, when we say two identical linear factors, means let's say x minus a whole square times x minus b, right? So that means at a we have two roots, right? Two zeros. Since it is cubic, we expect three zeros. So that is, we have three zeros, correct? Two are identical. which will give you the identical, will give you two zeros at a point. So we get a factor x minus a whole square. Perfect. Now what we are going to do is expand this, and then we are going to equate the terms and find the value of a and b. Okay, so let us expand x minus a whole square. So we have x minus a whole square means x square minus 2ax plus a square, and we are going to multiply this by x minus b, right? So x cube minus bx square, then multiplying with minus 2ax, we get minus 2ax square plus 2abx. Now we'll multiply by a square, both the terms, plus a square x minus a square b. Okay, so this bracket is not required here. We can now see rearrange the terms. As far as bx square is concerned, there are two terms with x square. So let's write this as, let me write minus inside itself, right? Minus b minus 2a x square, and here we have x terms, 2ab plus a square x, and the constant minus a square b. Perfect. So now you can actually compare some terms. The coefficient of x square is minus b minus 2a, and here it is 3. So both should be equal, right? So that means 3 is equal to, I wanted to write 3, the coefficient of x square 3 is equals to minus b minus 2a, correct? Now from here I can write what b is equal to. So b is equal to minus 3 minus 2a. We'll call this as our equation number 1. Now comparing the coefficients for x square, we can now write down the second equation, which is minus 9 is equal to 2ab plus a square. We can substitute what b is. So minus 9 equals to 2 times a times, instead of b, I'll write minus 3 minus 2a plus a square, correct? So this could be written as minus 9 equals to, let's open this, minus 6a, and that becomes plus 4a square plus a square. Correct? So that becomes our equation. We can find the value of a from this particular equation. So we have bringing minus 9 to the other side gives us 0 equals to 5a square. Okay, this is negative. This is also negative. Wait. 2a times minus 2a will be negative 4a. So we have 0 equals to, it's better to bring this to the left side now. I want to keep the x squared constant, positive. So 4a square minus plus a square becomes 3, right? So we'll bring it here. So 3a square plus 6a minus 9 equals to 0. So that becomes the equation, which we can now factor. 3 times 3, 9 times 3 is 27, right? We can take 3 common. So dividing by 3 gives us a square plus 2x means 2a minus 3 equals to 0, right? Okay, let's factor this. A square plus 2a minus 3 equals to 0. So factors 2 and 1. So we get a plus 3, 3 and 1, and a minus 1 equals to 0. That means a is equal to minus 3 or a is equal to 1, correct? So we get two values, a is 3 or minus 3 or 1. For these two values, we can find what b is. Okay, so if a is minus 3, substituting minus 3 for a, b is equal to what? Minus 3 minus 6 plus 6 will give us plus 3. And if a is 1, substituting 1 here, we get minus 3 and minus 2 as minus 5. Right? Substituting 1 there, we get minus 3 minus 2 as minus 5. So substitute 1, right? So b equals to minus 3 minus 2 times 1. This is what we are trying to say is minus 5. Now what is k? The constant k is basically the product minus a square b. You see that? So k basically is equals to minus a square b. We have the values for a and b, we can substitute. So one of them being minus 3 and 3. So if I write minus 3 for a, so I get minus 3 square times 3, and that gives us minus 27, correct? So we got one of our solutions. The other one, there's less space here, so I'll just push it forward. So the other one is when I substitute 5 here, so k equals to minus a is 1 times minus 5, and that gives us plus 5. So we get both the values, plus 5 and minus 27. Is that clear to you? That is how we are going to solve it. A very challenging question, right? I hope you appreciate it. Let's look into this solution, which I have neatly typed out for you. So basically what we have done is that since we are given that it has two identical roots, so we wrote the function as product of 2, x minus a whole square and x minus b. Expand it. Once you expand, then you can equate the terms. That is, compare the equations. So when you compare the equations, you get b plus 2a equals to minus 3 or b equals to minus 2a minus 3. And the other one is 2ab plus a square equals minus 9. Solving these two equations, we get the value of a and b. Remember, the value of k, which we are interested in, is basically minus a square b. So once you get these two values, then do minus of a square b to get your answer, which is going to be 5 and minus 27. Is that clear to you? Perfect. Okay. So now let's move on to our last question. It's an application question. It's a pretty challenging question actually. A cone is inscribed in a sphere of radius 2 centimeters. Determine volume of the cone in terms of x, v of x in factored form. Write the domain of the function v of x. So that's a sphere given to us whose radius is 2 centimeters. That is the value of x in whose terms we need to find the volume. So I'll actually provide you with a general solution. Since this is a very important question, and we'll assume that the radius is r, right? We are given radius is 2, but we'll use the value r. Okay. So let us say this is r, so that means all these things are r, correct? Now what is the volume of cone? Volume of cone is 1 by 3 pi r square h, where lowercase r is the radius of the cone. So this r we need to find in terms of x. That is the whole thing, right? Which is simple. We can say Use the Pythagorean theorem here, right? So what is r square equals? So r square is basically equals to capital R square minus x square, right? Since we need r square, we can keep this equation. Let me call this as equation 1. Now we have to figure out the height. Now height is e to d, right? Which is capital R plus x. So we know both the things. We can now write down 1 by 3 pi. R is r square minus x square, and the height is r plus x. Is that clear to you? So I'm using a general value r. We'll substitute 2 later. So 1 by 3 pi, this can be factored. Do you see that? And now we can further combine the two terms, which is r plus x whole square times r minus x. You get the idea. So we get the volume as a function of x, right? So volume as a function of x, which is 1 over 3 pi r plus x whole square times r minus x. Perfect. So that is the solution. You can always substitute 2 for r, right? So if I substitute 2, we get 1 by 3 pi 2 plus x whole square times 2 minus x. Is that okay? So for r equals to 2, as given in the question. Now the second part to this is, what is the domain of the function? So how do you find domain? So as you can see, in this particular equation, r could be, the value of x has to be greater than 0, right? And less than r. If the value of x is minus 2, then what happens? You get volume as 0. So for x between plus and minus 2, you get volume 0. So what do you notice here? If I use the general equation, I can write x is between minus r and plus r. Now some of you will be surprised to see why am I writing r as minus x as minus r. Can x be negative? Can x be negative? Very important question. Now let us try to visualize this. See, the x is from center to center of the sphere to the center of the cone, correct? Now, if x is equal to r, then we'll be at this point, correct? So let's take case 1. X equals to r. In that case, the volume will be equal to 0 because it will be a straight line. Do you see that? That is x equals to r. How about case 2? X equals to 0. So x equals to 0 basically means the sphere is here, right? At this point, we have a cone and we form this cone, correct? At this position, x is 0, right? So if x is 0, we get the volume as equal to 1 by 3 pi r cube. Now what happens in case 3 when x is equal to minus r? Minus r means, see, as soon as you move up, in that case what happens? My cone becomes here, right? The distance below C is positive and above C is negative. So the negative distance is actually from the reference point of C. As you can see, as you go up, volume decreases. It becomes 0 when you are at E, and at that time x is negative x. negative r. You get the idea. So x is negative r. That means you are at point E itself. In that case, the volume is again equal to 0. So, as we have shown here, the domain is actually going to be from minus r to plus r. You could also, for x equals to r, for r equals to 2, as given in the question, the domain will be from minus 2 to plus 2. Is that clear to you? So have a good look at the solution shown here. Understand the concept. This is very important. Understand the concept. Now we could have a negative value for x. That is to say that we have a cone which is right there. So this cone has a negative value of x. Is that clear to you? So that becomes very interesting, and I hope you have understood this concept. It brings us to the end of our solution to these 4 questions. Once again, let me remind you that we have seen how difference of cube and sum of cube can be factored and applied in some cases. These are one of the best examples seen in previous test papers. I hope that helps. Thanks for your time and all the best.